Hello friends, welcome to today's mathematics class. In today's class, we are going to be learning quadratic inequality. So like we all know, quadratic inequality is not solved the way we solve normal quadratic equation. Because at the end of the day, we're going to be testing for set of values. So inequality has to do with range of values that will satisfy the expression. Now, the first thing we need to do now, let us go solution. So first thing we need to do here, you need to get the critical points, okay? Your critical points. Or you can get the critical values. That's what we call the roots, okay? The root of this expression or this inequality. So what you need to do is to set the left-hand side to be equal to 0, which is minus 5x minus 14 equal to 0. So we need to get the values now for x, the roots of this equation. They are called the critical values. And that point is called the critical point, where it will cut the graph, the x-axis. Now, what we're going to do now, let us use a factorization method. Okay, open your bracket, don't waste time. Then put x here, close the bracket, equal to 0. Now we see that what here, this negative 14 here is the product. So it means our two factors of 14 that will be negative. Okay, two factors that will give us multiply together to give you negative 14. Then when added together, it will give you negative 5. So minus 2 times minus 7 will give you plus 14. We don't take that. Then we are going to change the sign. Now let us put plus 2 times minus 7. It will give you minus 14. It will give you minus 14. Now we can also say minus 7 plus 2 to give you negative 5. Negative 5. So which means the right combination of the factors is this one, minus 7 and positive 2. Now let us go with that. Now what we just need, we just put it into the brackets. So we just put x minus 7, then x plus 2. Or you can put x plus 2 first. You can say x plus 2, then put x minus 7. Now, to get the critical values now, we set this one to be equal to 0 because it becomes a quadratic equation now. X plus 2 equal to 0 or x minus 7 equal to 0. So we can have x equal to negative 2 or x equal to positive 7. So this is known the solution to this inequality. What we are going to do now, we are going to test for values now. This is just the critical point. We are going to look for interval where the values of x can lie on that will satisfy this quadratic inequality. Now the interval, we can use number line. Let us create our interval. Okay. Intervals. We are going to be having 3 intervals. When x is less than this, negative 2. Okay, that is the first interval we're going to have. When x is less than negative 2, let's say starting from negative infinity, then getting to negative 2. That is the first interval. After that interval, we are going to look for a value where x will lie between negative 2 and this 7. So let's check the values of x here that we satisfy this inequality. Then the last one, we are going to be testing for when x lies ahead of 7. That is from infinity, that from 7 to infinity. So we're going to be testing these points. First of all, take a value from here between negative infinity to negative 2. So any number that is less than negative 2 can be tested. So we can test negative 3, negative 4, negative 5 as the case may be. Or on your number line, what I'm actually saying is this. This is your number line, okay? For your proper understanding. And here is 0. We have the right hand side positive, that is 1, 2, 3, 4, 5, 6. Okay, let's extend it. Then 7. Let's call this a -1, -2, -3, -4. Now, let us check now. This first interval falls within this left-hand side. So this one falls within here. And now between -2, from here, from this -2 here, down to this 7, down to this 7 here, that is where the second interval falls to. Now, when you exceed 7 towards the right, so it means x can take a value from there that may likely satisfy this inequality. So first of all, let us test the first interval. Okay, let's go. Now, test x is less than what? -2. We are testing for x less than -2. So that is where we then choose any value. We then choose any value. Let's say -3. Okay, because -3 is less than -2. Now, in which interval? In this negative, then to -2. Now, what you need to do, just plug it into the original expression here. If it will give you less than, oh, we need what? A positive result. It must be greater than 0. So if it gives you a positive result, a positive value, it means the set of values there can be what? Taken. Now what? Let's go. Now put -3 into that expression, which is x squared minus 5x minus 14. Now putting there -3 all squared. Remember, it will be squared like this. Let's go. -3 all squared minus 5 into -3, then minus 14. Now let us see if it will give us exactly 0. -3 squared is 9. Then minus times minus is plus, that's plus 15. Then minus 14. So now let us go. At that point now, it will give you n. This is 24 minus 14, which is 10. So 10 is greater than 0. So that means that what? At this point, the value here is true. We are going to consider this because it is what? Positive or positive. I said that it must be a positive value. Okay, this is positive. And where did we test for? What was the test? We test for x less than -2. So we tested for this, x less than -2. That is what we just tested, okay? Now let us come to this point now, the second interval. Second interval is where we have -2 and what? +7. Now, what are we testing for here? We have to test x greater than -2 but less than +7, okay? So we are testing x. This is -2, x greater than -2 but less than 7. This is what we are testing. Now choose a value here between -2 to 7. So we can just take 0. Okay, can choose any value. Can you take -1? Can take 1, can take 5. Now let us put x, okay, equal to what? 0. Let us test it now. Put it to the expression. We have 0 all squared minus 5 into 0 minus 14. Now let us see if this will give us exactly greater than 0 or not. So this is 0 minus 14. So, and this will give us minus 14. Now it is not greater than 0. So this one is less than 0. So this is false. So we ignore, we shall reject this. So this one is for false. So we reject this. We are going to reject this. So now let's go to the last interval where we have 7 and infinity. So this means that what? We are testing for x greater than 7. Now choose any value of your choice. Now let's take 8, immediately 7. So we take 8. So test x equal to what? 8. Let's put it there. So it means x squared, okay, Let's plug it into the inequality. We have 8 squared, then minus 5 into 8 minus 14. Now, what do you think this will give to us? 8 squared is 64 minus 40 minus 14. So what will this one give to us? I think we will still have 10. This will now give you 64 minus 54, that's 10. And remember, 10 is greater than 0. So therefore, this one is true. So every set of values here can be taken. So that means true or positive. So it is positive. So we take the values from here. Now, our required solution now, your answer to the question, answer to this question. Number 1, the first point we take values is where x is less than negative 2. We have x less than negative 2. And this last point where we are going to take set of values is where we have x greater than 7 and x greater than 7. So these values here satisfy the inequality. This is how to solve quadratic inequality. I hope you understood this process. So I had to take time to make sure that I explain for proper understanding. Please help us to share this post so we can reach out to greater number of students on this platform. Bye.